Just here. Let's review. Somebody want to read to me this paragraph, please? Go ahead. You have it in front of you, so go ahead and read loudly.
The heating system of a house works to keep the temperature consistent. If the house gets too cold, then the heat automatically turns on to warm the house. The heat stops when the preset temperature is reached. This is an example of a feedback mechanism. Organisms use many feedback mechanisms to either maintain or amplify important chemical systems. This could happen at a molecular level to coordinate the function of a single enzyme, or it could happen throughout the body to regulate the organism's internal temperature.
So there's a lot in this paragraph to unpack. My guess is most of you only read it, barely skimmed it, and didn't understand a lot of the words in that paragraph. I had a class that wasted a lot of time yesterday, and I was wondering how they could be wasting so much time going right to the questions and trying to answer the questions, then coming to me and asking me to help them answer the questions when the answers were right in front of them. All they had to do is look up some important words, vocabulary words, and then find the meaning in the paragraph in context. So why don't we go ahead and break down the sentences and the paragraph and find meaning in this thing that they've written. Heating system of a house works to keep the temperature constant. Now, we have mentioned it. We described that the day before yesterday. And we looked at a chart, and I said, if we set the temperature at 70 degrees Fahrenheit, the temperature can go up, and something happens, and the house will bring that temperature down, and then the house then reads that, and it brings the temperature up, and then something else happens if it gets too high. It brings it down and then up and down. I drew that on the board 2 days ago. And I said, this defines a range. And I said, here, this is too hot. Too hot, T-O-O, meaning more than the limit. And this down here is too cold, more than the limit. So you have to have, first thing you have to have is something that senses the hot and the cold. We said we have this thing called the thermostat, and the thermostat has, as part of its mechanism, a thermometer. Thermometer. Meter means measuring device. Thermo means heat. So when you look at the word thermometer, all that means is something that measures heat. It recognizes heat. Heat, by the way, let's define heat. Let's define temperature first. Temperature is the average kinetic energy. Remember, kinetic energy is the energy of movement. So everybody should be writing this stuff down, not staring off into space. I know some of you still maybe sick from all the paperwork, from all those blue and yellow papers. You like my sass? No? I thought it was funny, but I guess you don't. Write in your binder, in your notebook, and then rip it out and put in your binder. Oh, you don't? You're taking notes right now. You can add them onto this. Did you not have a copy of this? Go get it. It's over here. It's right there. The notes that I'm talking about that we did 2 days ago, I already sent to you. And you got those notes? Okay. So average kinetic energy is temperature. And so it's an indirect way of measuring heat. So the a thermometer, measures heat. Then as part of the mechanism, the word is, some people didn't know what the word means. They read it as machine. It's kind of they're related. But the word is mechanism. Does anybody know what the word mechanism means? It's a series of, that's a good word. That's a good word. I like that word. Can I say a series of actions? Series of actions that leads to a functional result. So in this case, you have a thermometer which is reading. We're going to use the word sensing. Is everybody okay with that word? What does sensing mean? What does the word sensing mean? Reading? Okay. Anybody have an idea what the word sense means? Besides making sense, not making, all right, besides that, what the word sense? Yeah, go ahead.
Like recognizing something, like your sense, basically, like, I don't really know how to describe it, but like,
Give me the 5 senses that you know of.
hearing, smelling, sight, tasting, and like, did I ever say
Touch,
touch? Yeah.
right?
Yeah.
Those are the 5 senses. We sense our environment. We sense changes, right? It gets hotter, gets colder, gets louder. You do sense the environment. Some of you, I wonder if you sense the environment. I really think there's some zombies in this room. Maybe they don't sense the environment, but the rest of us do sense the environment, correct?
Yeah.
All right, so we have machines that can sense the environment too. The thermometer senses heat. And so we sense, we have to register the change. Then, as part of the mechanism, is that sends a signal, electrical signal, to what? If it gets too hot, if it gets too cold, if it gets cold, if it senses cold, it sends a signal to what? The thermometer, in the case of the heater at your house that I described 2 days ago and that you read about yesterday. If it gets too cold, the thermometer sends an electrical signal to what?
The thermometer.
The thermostat is inside the thermometer. The temperature in the room the house is getting too cold. It sends a signal to the furnace. That leads to a bunch of different steps that turns the furnace on. And you get fire. That mechanism that leads to the result. What is the response? What we call the response is what? The furnace turns on. What's the ergo? Heats up. Increase in temperature. So if this is the response, to increase in temperature, what was the stimuli? What temperature? That's right. Stimuli. The stimulus, let's just say stimulus because it is one thing. The stimulus was the cold. So it being too cold was the stimulus. That led to what? That led to a response of increased temperature. That increased temperature happened because of the furnace turning on. So there was a mechanism, right? What was the mechanism? The furnace turning on. The signal was the electrical signal sent by the thermostat. But the stimulus in general was it got cold, right? And the response was an increase in temperature. Do you agree with all that? Now, what happens, and I'm going to go ahead and draw another thermostat here. That's what happens when it gets cold. But what happens when it gets hot? Well, if it gets too hot, and I should say, we should be very clear when it's too hot and too cold, because there's a range, right? It gets too hot, what does the thermostat do? It sends a signal to what?
To a cold system?
Well,
Air conditioning?
well, it could in the summer, but let's just keep it simple. Keep it with the furnace. You're right. It's not that you're wrong. It's not that you're wrong. But what's it going to do? What's it going to send a signal to the furnace to do if it gets too if it gets too hot?
Oh, to cool down the room.
No, it's not too cool down the room. What is it? What is it? What is this signal to turn off? That's right. It tells the furnace to turn off. So now the furnace is off. Okay. What is then? That's the mechanism. The mechanism is that it senses the change. It sends a signal. And then this is the machine, it turns the machine off. The response is what?
The temperature dropping.
That's right. The temperature drops. And so you also get the response, and this was a stimulus. So you have a stimulus and you have a response. With a mechanism, what was the mechanism? The thermostat sensing it, sending a signal to the furnace, it turned it off. The resulting response is the temperature went down. Everybody okay with that? These two, if you drew them and kind of in a schematic, rather than without all this detail, sketch a schematic without all the detail, you could draw a thermostat. You could draw a series of arrows. And each side, this is what happens. If it gets too hot, this happens. And if it gets too cold, this happens. In both these cases, if the stimulus is increased temperature, the stimulus is a decrease in temperature, cold, right? And the response is the temperature going up, is it positive or negative feedback? Move that book bag from in front of you, please. What is it, negative or? Okay, whatever. Your eyes were down and to the screen. That's why I was wondering. I am looking at you when I'm talking to you because I'm talking to you. I keep saying that. I mean that to everybody in the room. Even if you're all the way in the back, I'm looking at you. I want to know. I'm talking to you. I want you to know that. I'm trying to teach you, not just these people up front. So if you have a cold stimulus and the response is heat, is that increasing the stimulus or decreasing the stimulus? It's decreased. They're opposite, right? They're cold and hot are opposite. We call that negative feedback. In this case, it's too hot, so the mechanism cools off the house, so we call that negative feedback. These are two negative feedback loops that help keep the temperature constant. These two loops keep the temperature around 70 degrees. Does that make sense, everybody? By going up and down. But it does this using what we call dynamic equilibrium. Again, this is a repeat of 2 days ago where I said dynamic means change, but we're keeping it equal. We're keeping it around 70. All right, so that's where it comes from, dynamic equilibrium. We're changing the temperature, the mechanism's changing in order to keep everything the same, stable, homeostasis. The whole idea, the big idea here is homeostasis, keeping everything the same. Very good. Same, still. Keeping everything the same, still. Temperature, pH, everything. Okay. So when that's a lot in one sentence, but you see how they were temperature constant. That took a lot to keep the temperature constant, didn't it? There goes a lot into keeping your hot, when you're complaining the room is cold or too hot or whatever, there's a lot into it. There's a lot of pieces and parts that I have not described here. This is not a heating and cooling class, so that's not the point. The point is it takes a lot to keep that temperature constant. Your body does a lot to keep your temperature constant. Again, if you get too hot or too cold, you will die. So it is important that you keep your body at a constant temperature. Yeah.
Is it the front or the back of our brain that sends it to our body?
Say that again.
Is it the front of our brain or the back of our brain that sends?
It's a good point. It's called the hypothalamus. It's in your documentation, in model 2, I think. All right. You sign in if you're late. You put your tardy pass down. Did you get a tardy pass from the office? Good. Sign in. The sign in's right there. If the house gets too cold, we already went through all that, right? So that's what all that was about. So I'm just going to highlight the stuff we already talked about. And we talked about feedback mechanism. Actually, we defined it as a negative feedback mechanism. So all that was just to understand this first half of the paragraph. Organisms use many feedback loops. Use a lot of feedback loops to keep alive. It takes a lot of this to happen. You need all 5 of your senses. You need something to measure your blood pressure. You need something to measure your glucose level. You need something to measure the heat in your body. You need all these different mechanisms to control and keep you stable. When you become unstable, you start the path towards death. And that is not a good thing. So organisms use a feedback mechanism to maintain or amplify important chemical signals, which we'll get into later. All right. So, but we did talk about that 2 days ago, when we talked about this idea of insulin. Insulin is a chemical that's known as a hormone. It's a protein. There's a small organ, which I cannot really draw. It's very small relative to your heart or what have you. It's called the pancreas. It sits near your intestines, and it releases insulin. It also releases, I think it's with an E, pancreas. Hey Siri, spell pancreas.
Pancreas. Pancreas.
Okay, so there's no E, I was right. All right, so the pancreas releases insulin, but it also releases another hormone called glucagon. This is just one example of a living organism using feedback loops to release chemicals. And the example we talked about, and we'll come back to over and over again, is this idea of keeping your blood glucose around 100. It could go a little lower. It can go a little higher, just like the temperature in the thermometer in the furnace. But you want blood glucose to stay around this 170, what have you. Well, we'll talk about that in a minute. So what these two here are the mechanism, these plus this, is the mechanism that your body uses to keep dynamic equilibrium so that you can keep homeostasis. In this case, a blood glucose. So your blood is here. Let's call it blood. And there's these little molecules called glucose. We draw them with little hexagons. You'll be very familiar with glucose soon enough. Glucose is a major, is the primary form of sugar in your blood. When you eat, the whole point is to get that glucose up. Your pancreas and your pancreas measures. Pancreas is what senses the concentration. Square brackets means concentration of sugar. Can I use sugar level for now? Okay, can I use sugar level? Is that okay? How much sugar or how little sugar you have in your blood? All right, so it senses it. The blood obviously circles in the pancreas. The pancreas has a mechanism. There's a mechanism that senses it. If the blood glucose is too high, if there's too much glucose in the blood, your pancreas releases, there's those arrows, insulin. Then that insulin goes into the bloodstream and goes to every cell, almost every cell in your body. There's a few cells that don't need insulin, but it goes to almost every cell in your body. It says, open the doors. So what happens is that the doors open in the cells. We'll talk about what those doors are. And the glucose goes into the cells. But if it goes into the cells, what's it leaving? The sugar is going into the cells. The cells are here, along the blood vessels. It's going into the cells, but what's it leaving? Where's the sugar leaving? The blood. It's leaving the blood. That's good, because there was too much in the blood. So now it goes into the cells. Your body turns them into fat or puts it away as glycogen, whatever, but it's out of the blood. Understood? That's incredibly important, because if that sugar gets too high, your blood turns into syrup, and then your body can't pump it correctly. It gets too thick, and it starts to do nerve damage, and you start losing your eyesight and your hearing and your feeling. Yes, it does happen a lot, too often. And your toes and your fingers start to rot, and they have to cut them off. This is not a good thing. So blood glucose is important that you get the blood glucose out. So that's what happens when the stimulus is blood glucose.
So that's why people use insulin?
That's right. That's why people use insulin, to get the sugar out of the blood. Blood glucose is too high. There's that word TOO again. Too high. If blood glucose is too high, the mechanism is the pancreas senses it. Blood glucose is too high. Insulin is a signal. This is the signal, by the way. The signal is sent to the blood cells, opens the doors. Then what is this? What is the response? What's the response to insulin? Glucose goes down in the blood. Everybody okay with that? Y'all need to wake up. I'm not going over this again. You're going to be tested on it tomorrow. So you better understand it. If you don't have a question, now's the time to ask it. Not just staring off into space, unwrapping your little candies, or doing whatever else is going on. Writing it down is only the first step. You have to understand it, be able to answer questions on this material. Yes?
For insulin, right? What happens if your insulin's low?
If your insulin's low, then blood glucose does not come down. And you have high blood sugar, which leads to high blood pressure, which leads to thickening of the blood, which leads to neuropathy or the destruction of the nerves, circulation problems, strokes, heart attacks, embolisms, loss of tissue in the foot and the fingers, all kinds of bad things, which is why diabetics that are insulin dependent have to take insulin.
They take it every day.
Every time the blood glucose gets too high.
Yeah.
So type 1 diabetics have to take it every day, yes. Multiple times a day. In fact, some diabetics have a pump that's connected to them. They have the insulin in and it just pumps it in whenever it needs it. Huh? It's a liquid. It's actually a very small amount, but yeah. It's a needle. You have to actually most people just take it with a needle.
Is that why Miss Perez got that one thing on her arm?
That's right. Miss Perez is a type 1 diabetic. I'm a type 2 diabetic. I'm not insulin dependent, but I do have to control what I eat. Otherwise, my blood glucose goes too high. Yes, question. That's a good question. Let's talk about what happens when the blood glucose gets too low. So the blood glucose gets too low, obviously, as you start to respond, your response is the blood glucose is coming down. If it gets too low, the biological response is you faint. You'll get dizzy, woozy. Then you'll faint if you don't eat sugar, if you don't increase the sugar, you'll faint. And then after you fainted, if you still don't get enough sugar in your blood, you can go into a coma. Then if you still don't get enough sugar in your blood, you die. So that's a really serious issue. That's acute. This is a chronic problem. This, too high blood glucose, it'll take a while before it starts to, you see a lot of negative repercussions from consequences from having high blood glucose.
So low glucose is more deadly than high glucose?
It's I wouldn't say more deadly. Some people really think of it that way, but it's not. It's not that it's more deadly. It's that the death comes quicker. So it's much more acute. The word is acute. This is a chronic problem, means over time, where low blood glucose is acute. It's an emergency. This is a problem. This is a serious problem that will kill you, high blood glucose. But low blood glucose is an emergency. So, if your blood glucose gets too low, again, what reads it? The pancreas. Pancreas reads it. It's too low. I'm going to put BG, blood glucose. So the blood glucose gets too low. What is the body going to do? What's the pancreas going to do? You'll have to make a guess. It sends a signal. What's the signal that it sends? Can anybody guess? Say that again. I didn't hear her. What'd she say? Getting dizzy is a consequence of the blood glucose getting too high. That is a symptom. We call that a symptom. It's not a signal. So it is a symptom. It is your body telling you, yo, you better eat. So that is true. But this pancreas sends a signal to the cells What is the, yeah, the pancreas is going to send a signal to the cells of your body saying, yo, we need sugar in the blood now. It's an emergency. What is the signal? Can you guess? You have to guess. Yeah. Insulin was the one that, glucagon. Excellent. So you have not heard of glucagon probably. A lot of people have heard about insulin, haven't you? But very few people hear about glucagon. So if it's too low, you're going to release another signal protein called glucagon. And glucagon is another hormone, another chemical. It's called a protein. Both these chemicals are called proteins. It sends them into the blood. Glucagon gets sent into the blood. That signal tells the cells, release sugar. That's a mechanism. Glucagon is the signal. The cells release sugar all different kinds of ways into the blood. What is the result? More sugar. More blood sugar. More blood glucose. So you have the stimulus is the pancreas. The stimulus is too low blood sugar is called the stimulus. Correct?
Yeah.
The result or the response is what? More blood glucose, correct. So the stimulus was too low blood glucose. The stimulus was too low. The response is more. So is that positive or negative?
Negative.
That's negative. Negative. Now here where you have the signal was insulin. Here, oops. Here the signal was insulin, but the stimulus was too high, blood glucose was too high. The response was bringing the glucose down. The mechanism was insulin to cells, take glucose out. What was that, negative or positive? Negative. So two negative feedback loops to help regulate blood glucose, just like the thermometer in your house. So that's just a general idea of how these work. Let's not call it negative response. The loop the feedback is negative. When they're opposite, when the stimulus and the response are opposite, we call them negative. That means you're slowing down whatever it is. The stimulus glucose was too high. You didn't make the blood glucose higher, did you? No, you made it stop. You made it go down. So you did the opposite. The same with when it got too high, when it got too low, you did the opposite. You increased it. So we call that negative. Is that okay?
Can you go back over?
Yeah. You need to write something down. Yes, question.
Does your body know when to stop producing? Like your blood sugar level is too low, and then it's trying to produce. Does it know when to stop and when it's enough?
Yeah, it does. There's a lag time, so it's not exact. It's not like a light switch. It's more like a dimmer. All right. So what happens is the pancreas reads too high. It releases insulin. The blood glucose starts to come down. You see the chart? It starts to come down. It'll go below 100, and it gets too low. What is your body stops making insulin, and starts to make glucagon. And before it gets to bottom, and then that starts to slow down the drop and starts to increase the blood glucose.
So it's just like a constant, either too high or too low.
That's right. Good. That's right. That's it. That's why we call it dynamic equilibrium. So we're keeping it the same, but it's going up and high. See, that's the kind of question we need to have, guys. We need to have those clarification questions. It's always a good thing to write those in your notes in your own words. All right? Say that again?
So positive feedback is like if your blood is if your blood sugar is so high, you eat more sugar.
Yes. That would be a positive feedback. Yeah, that's really bad for you, but that's not one that and that's why positive feedback in general destroys homeostasis. It can be good, and we'll see an example of positive feedback being good, but negative feedback is your body's tool for keeping everything the same, keeping homeostasis. Yeah.
I also didn't understand like how it says with for the negative feedback, the stimulus is decreased, but for positive feedback, the stimulus is increased. For me, like, why is it for the negative the stimulus decreases? Because it seems like it's just a constant of nonstop.
That's a good question. Excellent question. Let's go back and look at the insulin one, and then we'll look at the temperature one, and we'll come back to that general term. Okay? Excellent question. I love that question. So you have insulin. With the insulin, what was the stimulus?
Too high blood.
Too high. We had a mechanism which had a signal, sent the insulin, it brought the glucose out of the blood. What was the response? More, no. What is it? There it is.
In the blood?
Decrease in glucose. It's on the board. Look at the result. The signal was the stimulus was the blood glucose was too high. The response, it says response, is what? Glucose coming down. So the stimulus was glucose. What did we do to glucose concentration? We decreased it. Right? We decreased the stimulus. That is negative feedback. So let's do the opposite.
Basically, like, the stimulus, the response would decrease it.
Right, the response decreases the stimulus in negative feedback. So here's another one. Here is blood glucose is too low. You sense it with the pancreas. You send out the signal glucagon. It releases blood in the glucose. And what's the response? More blood. So low blood glucose did the opposite. It reduced the low blood glucose, didn't it? It brought it higher. Is that fair? Mm-hmm. Okay, you did the same thing with the heat. I don't want to take too much time by going over it again, but I'll do one of them here. It got too cold, right? Mm-hmm. Your thermostat sensed it. It sent a signal to the furnace. That's the mechanism. Which the response was what? Increased the temperature. So you lowered the cold. You took away the cold by adding heat. We all agree?
Yeah.
Opposites. So that's why they say you have a stimulus, whatever that stimulus is. Low blood glucose, high blood glucose, cold, too hot, whatever. It sends a signal. That response is the opposite. It decreases that stimulus. If it's too cold, it reduces the cold by increasing the heat. If it's too hot, it reduces the heat by turning off the furnace or turning on the air conditioner or whatever. If it's too high blood glucose, it sends a signal. The response is bring down the blood glucose. If it's too low, the response is bring up the blood glucose. That's negative feedback. Positive feedback, you get the stimulus, but then you increase that stimulus. You have one in the document in this, and let's go ahead and finish this page, and then go to the next page, and we'll look at that. Two types of feedback mechanisms. We just talked about them. What are they? Positive and negative. Define the words that are used in everyday language. Stimulus causes a mechanism. And you can put a lot of answers here. You can say action. You can make it real simple. I'm just writing one. Okay, a lot of right answers here. Causes a mechanism to produce a response. The signal does what? Starts, you can put a lot of different ways. Starts the mechanism, the action. Starts the mechanism. In fact, we can, why don't we, when it starts, sets off the mechanism. Let's just start. Starts is fine. Everybody okay with that? Response.
A reaction to the mechanism.
Is caused by, just going to be a real simple, is caused by the stimulus. The response is caused by the stimulus. The stimulus causes the response, and the signal starts the mechanism. Are we okay?
Yes.
All right. Identify at least 3 similarities and 2 types of feedback mechanisms. In both types, you have a stimulus. That's right. You have a stimulus, then that leads to a signal, that through a mechanism leads to a response. Everybody okay with that? All right, let's move on to the next one. So in this case, number 4, it says, imagine you had a puppy, you throw the ball, he chases after it, and you say, good job, you rub. Which is the stimulus? The stimulus is what? Puppy chasing the ball. I like who said the rubbing the dog's belly? It could be, depends how you look at it. In this problem set, because of the way they phrased the question, it's opposite of what you were thinking. But you're right, it could be that. All right? So puppy chased the ball, the response was what? Good job. All right? So when we look at, is the puppy likely to chase the ball next time you throw it? Sure. Justify reasoning. If I throw the ball, not I throw the ball. Let me just make it quick. Puppy chases leads to good job leads to more chasing. Right? So the fact that he chased it was a stimulus, the response was good job, that led to more chasing. Positive. The stimulus was puppy chasing. The response was more chasing. So you said positive result. So identify the portions of the scenario where this as stimulus and response, puppy chasing the ball, that's a stimulus. And the good job was the response. The response will get the puppy chasing the ball more. That's what puppies do. Is the scenario positive or negative? It is positive. It is positive. because the response will increase chasing. What if the stimulus is your puppy peeing on the rug? The stimulus is the stimulus is the puppy peeing on the rug. What's the response? Bad dog. And put it outside. Is that going to increase or decrease the pee? Decrease. So is that negative or positive? See the difference? All right. Later in the day, the puppy urinates on the couch. You said no, bad dog. You put the puppy outside. Is the puppy likely to urinate on the couch again? No. Because the response was to discourage the stimulus. Identify the portions of the scenario of the stimulus and response. Puppy urinating couch is the stimulus. The no bad dog is the response. Everybody agree with that? Am I getting it all right? Yeah. All right. Is the scenario example positive or negative feedback? You tell me. Is this positive or negative? Negative. This puppy example is negative. Which feedback mechanism in Model 1 would be most useful in amplifying, making things happen more often? Which do you think? The positive feedback is correct. Positive feedback makes things happen more. Negative feedback makes something happen less. Whatever that means. Which feedback mechanism in Model 1 is most useful for stopping the condition? Negative. If you have high blood glucose, you want the negative if you want to stop it from being high. All right? So, when we're looking at this part, it looks confusing, but it's just basically the same thing, guys. Same thing. Don't be surprised if you come in for the makeup quiz and you see this on the quiz. So hypothalamus, it says here that the hypothalamus senses the temperature. The hypothalamus is part of the brain. Hypo means under. Thalamus is another part of your body. So hypo means under the thalamus. It's anatomy. So in both cases, you're talking about the hypothalamus. And it's sensing, just like the pancreas did in the previous example. The pancreas sensed your blood. This is sensing your temperature. You have all kinds of sensory parts in your body that don't necessarily report to your brain. They do stuff without talking to your brain. They do it to control keep you at a set under normal conditions. So if your hypothalamus says, "Man, our body temperature is too low," it's pretty much saying you're cold, right? The body temperature is too low. It sends a signal. And it doesn't say what signal, but it sends a signal to your blood vessels. What's it going to do to your blood vessels if you're too cold? I'm underlining. You see me underlining? Blood vessels do what if it's too cold? Now I'm going to say it again. Blood temperature is too low. That means cold. It means cold. time is it? Oh, you're running because you're getting it passed. I see. Blood vessels. What happened to the blood vessels in your body? What do they do if it's too cold?
Blood vessels and skin.
They constrict. They get smaller. That means you lose less heat, so you can stay warm. That also gives you goosebumps on your skin. The contraction of the blood vessels makes your hair stand up. You get little bumps. Your little pores close up. And you do that to keep as much heat in as you can. Yes, question. Is the other person back? All right, you can go. So when you're cold, one of the first things that sends a signal. So this is what's sensing. What's the stimulus? Before I even go any further, what would the stimulus here be? Temperature's too low. That's correct. Somebody said it. If the hesitation really concerns me. Say that again.
It's just the hesitation was that it's just awkward for me.
Okay. Is everybody else feeling the same way? Here's what I don't want. I don't want you to sit there quietly and ignore what's going on, kind of blank out. And then I tell you that this is me going over the answers. You had a whole day to do this on your own. At this point, I should be giving you should just be writing down the answers and checking what you already did. Is that not what happened? Are you all staring into space because you wasted time in class, because you didn't feel like you understood? I don't know. I can't tell because you're not asking questions. You're not communicating. But thank you for letting me know why you thought it had hesitation. Everyone else, if you're hesitating because you don't understand, then ask a question. Take notes. I don't see people writing. I'm talking. I'm writing the answers on the paper that's due. The final paper will be due on Monday. So, stimulus is cold. What's one response? Has two responses. One response is what?
Blood vessels and skin constricted.
So that's one. That's this, right? And it's reducing heat loss. So you get less lost heat. Okay, that's good. And what's the second response? So that makes heat. So you have less loss of heat. And here you're actually making heat. So two together really help you. So when you feel goosebumps and you're shivering, you're making heat. You're keeping yourself warm. That's because your brain did this. When you're shivering and you get goosebumps, and you feel your skin tightening up, that's your body, your hypothalamus, your brain telling your body, do this, man, we're getting too cold. Yeah. Yeah.
I have a question, by the way.
Yeah, go ahead.
So at home, I have a heated blanket and a fan. Is it okay if I use both at the same time?
Yeah, it doesn't matter. So be careful electrocuting yourself, but yeah, whatever makes you feel comfortable. It's about getting comfortable.
Or yeah, I be having my heated blanket under me, like over my bed.
If it works for you, I personally am always afraid of heated blankets because laying on top of electrical wires always just makes me kind of, I don't know. I'm sure it's safe, but. All right, so you're making heat and you're decreasing heat loss. And remember, your normal body temperature, most of you should know, is around 36 to 38 degrees Celsius. It's like 96.5 degrees Fahrenheit, something like that, 98. All right? Everybody good with that so far? Is this confusing to anyone? All right. Was this positive or negative feedback? It gets cold, so you decrease heat loss and increase making heat. Someone said negative. Why? It's correct. You got it. That's absolutely right. Situation A in Model 2. Let's call it Situation A in Model 2. Situation A. This A, is it positive or negative? It is negative. Why would I have assumed it was negative? Why is it something that I would think it's probably negative? What do we want to see when if we were graphing the temperature where we have normal, what would that be? Would be 36 to 38 degrees. And we have a temperature that's too high and its temperature that's too low. And then we have normal, then put normal in green. What kind of feedback would I expect to see as the temperature gets too high? And we're going to make it come down. We want it to come down. And as it gets too cold, we want it to do what? Go back up. What does this look? Does it look like anything you've seen before? Have you seen this before? Yes, you have. Right? So we expect it. That's right. It looks like the same as your cardiac rhythm and anything else. You want it to keep going up and down, up and down. That's how we keep homeostasis. We want to stay around a normal temperature. You and I, all living creatures, have some kind of normal. We want to stay here. If we get too hot, we die. We get too cold, we die. We want to stay in the normal range. The only way we do that is with dynamic equilibrium. We keep changing back and forth. We need negative feedback loops. So we expect to see negative feedback loops. Do positive feedback loops give us homeostasis? No, it destroys homeostasis. Positive feedback loops are only designed to get something done, like giving birth, like making a blood clot. If you want more, do more and more of it until something gets done. This is never done. You never stay perfect. You're either always shivering or shivering and sweating, sweating and shivering, putting a blanket on, taking it off, putting a shirt on, turning a fan on, putting an electric blanket on. You're constantly changing. You never stay exactly the same because the temperature is always fluctuating. You're always getting too hot. You go up and down the stairs, you get too hot. You sit there sweating for a minute and you get too cold. You drink too much hot tea, you get too hot. You're constantly changing, up and down, up and down. We call that dynamic equilibrium. That changing so we can stay the same temperature. Your core temperature does not change unless you're sick. Unless you're sick or you're under extreme conditions, this temperature always stays the same. Is that clear? So this temperature, the whole point is to keep the core temperature of your body constant within that range of 36 to 38. All right. So what happens when you get too high? What does your body do? It dilates it dilates your blood vessels. So when you're out working out or you see people turning red, why are their faces red? Why are they sweating? They're hot. And what's the body doing? Trying to cool down. So it opens up the blood vessels so the blood rushes to the face. So they get a red face because they're trying to get that heat out of their blood. So they open up the blood vessels and get the blood near the surface so the heat can transfer to the air. So you call that. So that's the dilation means open. So normally your blood vessel looks like this under heating conditions, and they might open up like this. So you get more blood to the surface, and of course the opposite happens in the cold. And then the sweat glands open up and they start releasing sweat. Why? Because that's perspiration leads to evaporation, and evaporation cools you off. So those are the two things. What kind of feedback is this? Negative again. It's always negative if you're talking about homeostasis. So in situation B is also negative. All right, based on what you see in the model, propose a definition for thermal regulation. Okay, that's true. But based on what you see in the model, what I would say is Based on, because it says based on what you see in the model. So you're right that the word thermal means heat, regulation means to keep the same or to control it. You can say control it. Thermal regulation in humans. You could say the hypothalamus. Let me zoom in. The hypothalamus senses the temperature. And uses two negative feedback loops to keep the temperature between 36 and 38 degrees Celsius. That's it. Using two feedback loops to keep homeostasis. That's the point. Keeping the temperature within that range. Keeping the temperature within that range. It requires the use of two negative feedback loops. If something gets too hot, your hypothalamus tells your body to sweat and to open up, dilate the blood vessels. If you get too cold, your hypothalamus tells your body to shiver and restrict the blood flow to those vesicles. This will be posted on YouTube this afternoon when I get home, and I will send it to you in Jupyter. In fact, I'll send you all the videos in Jupyter with little labels. May I go on? Not yet. All right, waiting a second. Still got 15 minutes. I think we can finish this page at least, if not the entire thing, depending on how quickly we write. Yes, you may. May I go on? Does anybody have any questions while we're waiting? Is there a confusing part here? Is there something that's like, wow, I'm not sure I understand. If I told you on Monday morning, for points, do you think I'm going to ask you something on Monday morning or Monday afternoon? Yeah, I probably am. If on Monday afternoon I ask you define positive feedback, 1, and 2, define negative feedback, could you do it? Because I'm going to ask you. All right.
I have a question.
Yes.
So negative feedback is like decreasing and increasing constant.
I like that. But here's what I'm going to say to you. What I believe is the best definition for negative and positive feedback. Negative feedback, the response does the opposite of the stimulus. Why don't you move, darling? Move so you're not talking all the time, you're not distracted. Yeah, just voluntarily move somewhere you need to move. Wherever you like, there's plenty of space in the room. Just right, be reflective. I'm distracted, let me find a way to get focused. Negative feedback does the opposite, the response does the opposite of the stimulus. That's it. If the blood glucose is going up, the response is you bring it down. If the blood glucose is going down, the response is you bring it up. If the temperature is going up, the response is bring it down. If the temperature is going down, the response is bring it up. So negative feedback keeps homeostasis. How? 2 negative feedback loops help reverse the direction of movement of whatever the stimulus is. So So that's the point. Is the stimulant negative feedback helps keep homeostasis because it doesn't let things get out of control.
It helps keep it within the range.
It keeps it within a range. That's really the key to feedback mechanisms. According, oh yeah, go ahead. Sorry, you had another one.
Positive feedback is like increasing.
What did you need?
Can you say what you just said?
Yeah, negative feedback is when negative feedback loop is when your response does the opposite of the stimulus. Positive feedback, it makes the stimulus do more of whatever it's doing. Whatever it's doing, the response makes more of it happen. And of course, the stimulus makes more of the response happen. It keeps going and going and going and going until something occurs.
So you crash and burn and go.
Well, crash and burn is possible if it's a bad thing. But if it's a good thing, it's a baby being born, right? If it's a good thing, it's blood stopping, your bleeding stops, right? Adrenaline is a really good example. You release adrenaline, your heart races fast. You get excited. The stimulus is a tiger is running after you to kill you. Your initial response is eyes dilate, heart races, you breathe heavier, and you release the signal adrenaline. Adrenaline is released. What happens when adrenaline is released? Your heart races faster, and you start running. And you hear a roar, which makes more adrenaline being released. Is the objective of adrenaline to calm you and keep you at homeostasis? No. The objective is to save your butt. Get away from the tiger. Once you get away from the tiger, then you can come down. And you can get to that homeostasis again. But positive feedback, you use it to get across the finish line, whatever that means. In case of a baby, it's giving birth. So the response makes the stimulus happen more, not less. All right, so that's positive and negative feedback. Make sure you can explain it and use it. Now let's talk about, according to Model 2, what portion of the brain contains sensors that monitor body temperature? Hypothalamus. According to Model 2, what are two mechanisms the body uses to cool itself? Dilate, blood vessels,
Oh, Mr. Mendoza, I ran into like Miss Perez and she asked for a pass, but your pass isn't up here.
well, you shouldn't be outside. You should.
Had to go.
Okay, but you can't go out without a pass. So that shouldn't happen. Why is my pass not up here? Who was the person before you who signed out? Rihanna?
asked her, she said she didn't know.
So y'all went to the bathroom without passes all this time?
People had to go.
It's on the floor, Mendoza.
It's on the floor,
Next to the trash.
next to the trash. You cannot leave the room without a pass. If you gotta go, you gotta find the pass or tell me there's no pass there. You can't just leave. You will be called out by the principal. I guarantee you. What's gonna happen is Miss President call me out and say, why is a kid out of the classroom without a pass? If that happens, when that happens, when it happens, I'm coming for you. Hey, poop rolls downhill. I get yelled at, guess who gets yelled at? If I get yelled at, yeah, I get yelled at, duh. But then who gets yelled? What's the response? That's the stimulus. The stimulus is me getting yelled at. What's the response? You get yelled at. That's called a positive feedback. No, it's positive. We're all going to be yelling in a minute. It's all positive. All right, just joking. Just joking. Dilate blood vessels. Dilate the blood vessels. That's one. What's the other one? Shiver. Let's just put shiver. We know we can reference it up there. So we already numbered them 1 and 2. What are the two mechanisms the body uses to heat itself? Oh, wait.
Blood vessels, skin.
Oh, wait. We reversed this. It's reverse. Blood vessels dilate. Dilate means get wider, so more blood. But to cool itself, you sweat. Should all known that. Somebody said, probably somebody said it. They probably just said it really quietly. And of course, the opposite when you're trying to heat yourself is you constrict the blood vessels and the second thing you do is shiver. All right. Consider the feedback loop that cools the body when it's too warm. Okay, cools the body when it's too warm. So I'm probably going to consider this one, right? Identify the stimulus and response. What's the stimulus? Too hot. And then what's the response? I'm going to put 1 and 2, which is blood vessels dilation, and sweat. And what does that do? That leads to cooling. Let me put it a different way. Lowering temperature. All right? Is feedback positive or negative? It's negative. Why? Because it's opposite. If the temperature is going up here, the temperature is coming down here. One goes up, the other comes down. They're opposite. It's negative. That's it. Keep it simple. Are we all good? Does that make sense? So I can promise you, those of you that decide to do the quiz on Thursday, redo the quiz, you're going to see this situation happening. I'll ask you about one of the two feedback loops here.